Okay, so this is the. Okay, so I just put some hints here, so you don't need them. Okay, so okay here, as you can see, I have a very short program here. So what is the goal of this basically this example? I'm just going to handle basically when I receive a sick child. Okay, so very simply I'm just going to do that. But so as I told you before, so basically using signal function is much more easier comparing to the sig action. So first of all, okay, so you need to install your signal. So and then you need to introduce, okay, you are going to handle which signal. Or here you can basically also you can pass the value corresponding to this basically to these flags here. And after that, so you need to pass basically the handler, okay. And after that, so okay, the program here I basically create by fork one child, and so this is the the body of the child. And after that, so this is the body of the parent. So it's just basically waiting, and after that, so return. So what is the handler? So the handler is just okay, it's printing that the child is terminated, and then wait for 10 seconds. So okay, but we don't need waits, I suppose, here. So okay, so let's compile the program here. Okay, so as you can see, so now we exactly know that when the child process is terminated. Okay. So here, okay, so you can also, if we put some sleeps here, so if I compile again one more time, so when I execute, you see that, okay, so I need to wait for 20 seconds, and after that the child terminates basically and send the signal to the parent, and parent try to collect the signal. Okay, so this is one example. Okay, this is one example that is just, it seems that it's very simple. Okay, so and then the program is just terminated. Okay, so any question or something?
What is 17? 6 is the
Oh, so, okay, 17 is the number of the sick child. Okay.
In theory, I can have the same handler and then discriminate on seed variable.
So you can, in order to verify when you have handler, you can check again that okay, you exactly received that. But the one thing that I should note here is that at the same time you cannot send multiple signals. I mean the same type of signals. For example, here, if I just wait inside of my handler, and so I'm handling basically a sick child, so I cannot. So, for example, suppose okay here the child is waiting for 20 seconds, right? And then okay, so let's compile one more time. Then I'm going to kill 17. So by kill command you can send basically so as you can see, the first one I send the first basically signal, and then okay, instead of waiting for the child in order to send the sick child, I just send the signal by myself through the kill command. Okay, but as you can see, so here I send it for the first time, it was okay, so I went to the handler, and then I'm waiting there, right? But so for the following signals that I send again, so it's just all of them is just ignored. Okay, so we cannot send multiple signals but the same type to the process. It's possible that, okay, I have multiple signals but with different types, is okay, but I cannot send the same signals to the process. Okay, so if it's clear, I go for the SIG action. And this is basically this is the one example for SIG action. So if you so as I told you, if you remember, so in order to basically to use the SIG action, so I need to introduce basically disposition, and disposition is just like introducing the struct SIG action. Okay, and here I'm going to basically do the same things just like before for a SIG child that I use signal. I'm going to do basically the same things but with SIG action. So I need to basically introduce a struct SIG action here. I call this SIG child, and then after that I need to basically it's just like I initialize the mask for the SIG child. Okay, so as you remember, so I told you, okay, the three elements are important. So the handler, flags, and also the mask. Okay, so I initialize the mask. Okay, so I empty the mask, and after that here I also put the flag to 0. I don't need that anything there. And after that also I need to basically introduce the handler here. I need to pass the, okay, I'm going to deal the handler with which function. So SIG handler and chld, and this is the function that I have it here. Okay. And okay, so and after that, so I have basically the same scenario. I fork, sleep for 2 seconds, and then exit, and also here wait. Okay. Okay, so we receive that one. And then finished. Okay. Okay, so this is the scenario for the SIG action here. Okay, any question? Something? Is it clear? Okay, so as I told you, okay, we cannot send multiple signals at the same time. So I want to also give you one more example regarding to this. So I told you, okay, the SIG action is much more flexible compared to signal. Okay, so by defining the mask here, so I can handle the, or maybe I can block the basically the some specific signals during the execution of my basically my signal handler here. Okay. Okay, so here okay, I'm going to have two types of signal. I'm going to introduce basically SIG user and also SIG init. Okay, so forget about the SIG child. So I'm introducing the SIG user and after that SIG int. But the point is that I want to just to handle SIG int when I receive a SIG user. Okay, so it means that, for example, SIG user is important for me, and when I'm just doing SIG user, I'm just handling the catching function of SIG user. I don't basically I don't need that. Okay, I receive anything at the middle. Okay, so I'm going to do that here. So first of all, I need to, so as before, I need to introduce the two SIG action here, SIG user and SIG int. And after that, the point is that here, so for SIG user, I just, okay, first of all, I try to initialize the mask. And after that, through the function SIG add set, because the data type of the, basically the mask, so it's a kind of SIG set, okay? So it's a kind of set of signals. So I can add something to the set of signals. So SIG add set, and I'm going to add basically SIG int to the function, to the mask here. So as you can see here, I'm adding the SIG_int to the mask of the SIG user through the function SIG_add_step. Okay? And in this way, I'm saying that, okay, if I receive a SIG_int when I'm at the middle of the handling function, so just block the SIG_int for me, okay?
If you repeat them.
So here I want, by adding the one signal to the mask by default. So this is the default behavior, but I can change that. I can unblock as well. But here I'm just talking about the default behavior. So as a default behavior, if I add one signal, for example here SIG_int, to the mask of the SIG user here, okay, I'm saying that, okay, if I'm at the middle of the execution of the handler, so I'm not going to receive any SIG_int, okay? Just block them, okay? So it's not a kind of ignoring signal, it's a kind of blocking signal, okay? Yes. So if I can yes, it is queued, but for each type of signal I can queue only one, not multiple.
Okay.
It is queued, but it is queued if I want to
So
unblock.
basically, if you send during the routine, during the
Execution routine
of SIG user 10 SIG_int, only the first, the other are refused.
Yes, the only one of them, so I can
it's
have.
queued.
Yes, but it's possible that if I add the other type of signal, for example, apart from the SIG_int, I'm going to add, for example, another type, SIG_hop as well. So also I can basically queue one type of those signal. For each type of signal, I can basically queue one of them. Yes. So here and after that, okay. So this stuff is the same as before. So for SIG user, but okay. So here I initialize basically SIG_int. So it's the same as the one that we had. And after that, I install the signal here. Okay, SIG_USR1 and SIG_INT. Okay. And here I sleep for 50 seconds in order to avoid basically terminating the process. And after that, so let's look at the handlers. So the handler for the int is just I got the SIG_int signal, okay. And the handler for the SIG user, because I want to just have a longer execution of the handler, I just put a sleep 10 seconds here, okay. So I'm saying that, okay, I'm starting and also I'm ending the sleeping, and in order to avoid the overlapping, so just I flush out the steady out through the flush. Okay, is that clear? Okay. Okay, so do you remember what is the meaning of ampersand when I add it at the end of one line? So what it means?
What?
Yeah, put it in background, but in the stopping state, or no? It's no. I send it to the background, but in which state? It's running, yeah.
It's running.
Okay. But if I want to send it to background, but not in the running state, so what? Remember that? It's Control Z, yes. But I suppose the first session we discussed it. Okay, so here, so let's send, first of all, SIG_USR1 to, okay, so I have these. So as you can see, all of these SIG_int are basically ignored, okay? But when basically the sleep is finished, so basically, as I told you, the one of them is just queued, right? So I execute only that one. Okay, so is that clear, everything? So okay, so for this session, in order to avoid okay, I'm the only speaker, so I give you one exercise. It's very simple. It's very simple. So try to handle SIG_kill. Try to. Okay. try to handle seek kill. So just write a very short program. So either you can use seek action or you can use signal. It's just, as you can see, it's just some lines, right? So try to handle seek kill. So when I send seek kill, so the number is just 9. When I send seek kill to the process, so we try to just print out something for it, okay, instead of killing the process.
Okay.
Okay. So let's see.